DraftScience video, a little different. Back to Ken. See if we can get a conversation of some kind happening. Video exchanges or something, maybe. I don't know. It's difficult to get anybody to yeah, do that. Argue physics. In any kind of constructive way. So he's very against relativity and bent space-time and all that kind of stuff, and makes this simpler argument. The one, I think it's a good enough argument. Nothing makes something, tells something what to do. Doesn't make a bunch of sense. He doesn't really get to the energy part that I think is the more important criticism. So he doesn't really deal with time dilation and other subjects. But anyway, he's kind of obsessed with this magnetism thing and doing the Tesla thing, and it's just kind of funny because he talks about the priesthoods and people revering the Einsteins and the Feynmans, and he's doing the same thing. He's just thinking that everything came out of Tesla's mouth was golden or something. And again, Tesla didn't really rationally make or describe a theory. He just kept promising that he had one, but it never showed up. Anyway, so there's there's a fundamental argument here. So he calls all quantum mechanics, quantum mysticism, and I'd argue the idea of there existing a quantum of function in the universe, a smallest bit with a smallest set of properties, is, in my opinion, a rational perspective, and fits under the idea of quantum mechanics as originally formulated quantum electrodynamics kind of a thing. And it only became a religion when they started giving too many properties to light, photons, and too few to the matter they were interacting with. But the idea of particles versus waves is still the fundamental argument. So where we both agree that Einstein was wrong, and that quantum mechanics is currently conformed, this bent space, relativity, and this idea of a wave duality. So he wouldn't accept the duality part. He would say it's all wave, and I would say it's all particle. It's all quanta, and photons are made of quanta. They are quanta, just quanta at a frequency. So I don't know whether he's wishes to take the time to actually read and critique my theory, but I mean his is sort of redundant to me. He just keeps saying the same things over and over again, and it's a little, there's no diagram of how this perturbation takes place. I mean, there's a guy who wrote it down here. He calls this, Mother Nature is simple. She's not a crack whore on drugs and blah blah blah. Force and motion, okay, duh. Inertia and acceleration, okay. That's yes, okay. That doesn't explain anything though. The existence of these things are also quantum mechanical features. And then he goes on capacitance and resistance. So one is essentially the density of storing energy. The capacity to store is a word to use, to change the density of energy on a surface or substance, and resistance would be the obstacle to the passage of that energy. And then you have permeability and permutivity, which really start going woo-wee for me. But that's supposed to say it. You're supposed to see those words, and then that somehow gives you a vision of function, and it doesn't do anything. I mean, I'm not saying all these people are, dishonest, but how does that explain anything? It doesn't do it for me. Um, so, and particles can explain it. Can explain the energy to move planets into suns, that attraction, and also explain the repulsion of magnets and the fields of electricity. And he again mentioned Feynman and his virtual photons and mocked the idea of it. But the point is that, yes, I would kind of mock Feynman for understanding that it appears as if this force is made of something, okay, this magnetic force and electrical, that there's a force that's made of something that's causing stuff to move, causing energy to be restricted or to be provoked into motion, electrons, and conceding the existence of that, and then just not recognizing that, well, why not make them not virtual, make them real, and just call them a radiation, and then go on from there. Because once you accept that existence of that radiation, it's not too big a leap to accept the existence of a radiation filling space. And again, the key word here is a radiation. His argument that there's this ether, spelled funny, that fills space. Presumably there's still some empty space, I'm not sure. It doesn't really explain the ether. But if I was to make if you were just to take a bunch of ball bearings and put them right next to each other and just fill a box with these things, you could sort of understand that if you poked one, it would bounce through all of them, and you'd end up with that vibration. And if you made it a frictionless, sealed container, that vibration would go forever. And so you could sort of understand that, yes, they're all still things, but they will move when it's their turn, so to speak, when the motion gets to them. And so you could think of a dead ether working that way, as long as you understand that you have some piece that actually is in motion to initiate the motion, kind of idea. But it's just easier just to say, well, let's just get rid of the bits that aren't moving and just deal with the ones that are moving and give them straight line vectors that would be kinetic. Then you don't need all the extra bits. You just deal with the bits that are active. The active bit, the active impulse that moves through is really an impulse of a thing moving. So you don't need this dead ether. It's of no value. And if you make it an active ether, recognizing that energy is very dense and that we're only seeing a tiny fraction of it in these spectrums we deal with of polarization and frequency. Alright, I think that's enough of an argument. So I'll play some of his video and I'll just jump through it and just comment on some of but these are the same critiques over and over again. There's no diagram. He says light isn't a thing, photons, that it's this perturbation thing, this vibration that somehow does travel in straight lines, even though he says everything's curved. He's constantly doing this hyperboloid. This doesn't really explain attraction and repulsion, especially at distance. It doesn't even come close at distance. I mean, the fact is that, as a real fact, if I had a dead, empty universe that was, 100 billion light years across, and I put two objects at two ends, they're eventually going to crash into each other. It'll take a time. It's a tiny, tiny little tugs they're putting on each other. But how does your hyperboloid theory, do that?
Difference than saying angels did it. Not 1 degree of difference exists between those two things.
Right. Well, I'm going to argue that your theory is pretty much the same kind of angels. It's just some sort of thing, some wavy, forcey, blah blah thing, some perturbation, and I'm supposed to understand what that means. And frankly, I can't. I can't conceptualize that as a real thing.
You can say virtual photons. You can say angels. And suppose there are descriptions in...
Right. So, but the point is that's how they behave. That's how the force behaves, as if it was a straight line, emitted substance that causes effects on the stuff it interacts with, like photons.
Using those things to make equations balance out, there's no difference. It's just absolute stupid, it's insanity, it's nonsense.
Well, obviously it is not nonsense in the sense that we know the force exists, and you're going to say it's this, whatever it is, this roundy stuff, but we know it's not roundy stuff that's coming out of an electrical wire. We know the force in its effect, okay, ends up being perpendicular. But that's sort of a deception, right? Because the force is coming out of a circle. So let's just see each electron is circular. Like, they're probably flat, but like a galaxy or something. So whatever goes in is getting polarized, and it's coming out as this force. And the force is coming out in that circle. But see, the trick of the circle is that these two elements of it get wiped out. The one going this way and the one going this way cancel each other out. And the one that doesn't get canceled out is the straight line, in effect. So if you have a whole bunch of them next to each other, it's kind of like wave Huygens kind of nonsense. But the end effect is that it ends up just being a wave, a straight line force in terms of how you would measure it. Because no matter where you measure from, the two side vectors will be balanced out except for at the ends. So anywhere in the middle of the field, you're going to have the impression that it's a straight line force, even though technically it's not.
These virtual particles are quantum ghosts. They talk about the speed of light and the notion of a warp to space-time. Well, time is a measure. It has no existence autonomous from motion. It is a measure of magnitudes and their vectors over a given period.
So, I mean, again, a measurement of magnitudes over a given period. No, it's a measure of the fact that it takes this thing called time for stuff to do stuff. It's not going instantaneous, and it's not infinitely slow. It's something in the middle, and something in the middle is what we call time. So something that's not instantaneous and it's not infinitely slow, well, therefore it's time. That one's kind of easy.
Time has no existence. What about space?
I mean, obviously time has existence in the sense that these things obviously can't get from here to there instantaneously. That's obviously not happening. Instantaneous events are not happening. Nothing's going from here to there instantaneously.
Space? Poincaré disk model. Space is not...
I mean, you claim that gravity is or something else is, and yet you don't have any evidence of that, though.
Nothing other than the after effect of the loss of inertia.
Yes, now the loss of inertia, meaning what? If I'm standing still, I lose my standing stillness? I mean, inertia exists in everything, moving or not moving. Inertia is just a state. It's kind of like, this is what you're doing at this moment. You either possess velocity or you don't possess velocity, but the point is, if you're going to change what you are, something must act on you. Now this loss of inertia, meaning somehow what I have evaporates, like all of a sudden the Earth just says, I don't have velocity anymore, I'm just going to stand still. That can't happen. Forces have to cause change in state, and state is inertia. Do you have some other definition of inertia?
It has translated into force and motion.
Force and then motion, I would presume. Force and motion are not the same thing. Force is one thing. Things are reacted to the force. Now, I would argue force is a material thing. The force is made of real things called tons. And they can be graviton or photon or magneton or electroton. But that's what they are. The electroton is probably just a magneton, just weaker.
Here we have inertia, and here we have force and motion. Oh.
Okay, so inertia is flat, which I don't understand how that's a comparison to inertia, and then pop it open, and now it's hyperboloiding, and now it's force in motion. Force and motion, or force in motion? I mean, force by definition, it's kind of superfluous to say force in motion. Force by definition has to have motion involved in its function. It's not a force if it's not causing motion.
The hollow part of this toroid,
I mean, causing at least the potential, extending potential to move. Obviously, the motion can be stored as potential energy.
it would be space. But it is nothing. It is nothing. It is the after effect.
It is nothing. It is the after effect. What does that mean? What space is? What, the body odor of the perturbation? The hyperboloid sweats a little bit and makes a stink. What is this? The after effect. Space is the after effect. How do I make anything out of that? Sorry, I don't want to be patronizing. I mean, maybe that makes sense to you, but that doesn't make any sense to me. Space is the after effect. I don't know what that means. Like the squish mark. I don't know how to. The after effect, like an earthquake and the buildings fall down. How do I cognize that as a meaningful description of reality?
This is a bubble. Space has no properties. Aristotle said this.
Right, okay, empty space, right, the nothing, wherever it may be. But again, you claim there to be an ether, so either the ether fills all space, or there's space and ether, but you haven't really been clear on that.
Newton said this. Nikola Tesla said this. Space has no properties. The notion.
Right, I would agree. So we agree that space has no faculties, no properties, no capacities, no skills. It's the absence of anything by what should be definition. And clearly that definition has been broken because they had to create another dimensional actor to explain the energy of gravity. So the dimensional actor, they decided to call it space, but they could have called it dimension X, bent dimension X. So they could have called it dimension X time and said it was doing it. I mean, they didn't have to use the existing empty space and say that was doing it. It would have been better, I think, if they would have called it something else, just to make it less ludicrous.
The space has properties, or the space on acts on one thing or another, is an absurdity.
Well, I agree. It's on its face, it just doesn't sound very right. So I've never ever believed that space was bent. I mean, they told me it was, but I said, no, you have to show me some of that. That doesn't make any sense. Something, I mean, it always seemed to me they could say all that, they could say that crap forever, and I was still going to say, no, something else is moving the Earth into the sun. It's not no frickin' bent space.
The notion of the speed of light. You know, light has no speed. It's a rate of it.
Okay, so light has no speed. It just doesn't make. How can you justify that statement in light of all the ways light has been measured as having a speed, and that it has a maximum speed? And I would argue that's all it has. I mean, the fact that it slows down when traveling through mediums like water or glass or some other substance is just a consequence of the fact that it doesn't travel a straight line when it goes through those substances. And that absence of a straight line means it takes longer. Obviously, doing this takes longer than straight line.
Production of a transverse phenomena over a given period of time.
Right, a transverse phenomena. So again, we're stuck with it's a coaxial, that's the word he uses a lot. A coaxial, blah blah, perturbation, transverse, blah blah. And how do there's like a cable, like cable TV. It's electrical wire running from the sun to the earth, and the light travels the full circuit or something, and that wouldn't make any sense because obviously the sun loses mass based on the energy, the photons it's producing. So it seems like a one-way trip.
You know, the very principle.
The fact that they keep going, when they don't hit anything, they just keep going forever, kind of defeats this whole coaxial idea that they're doing any going and coming back. I suppose if you were going to argue they do all that instantaneously, then distance wouldn't matter. But why does it take time then? I don't know. I'm just saying, if this is what you think a simple explanation looks like, I don't know. I don't know what to say. I mean, I'm honestly saying, even if I didn't have my own perfectly rational theory, this wouldn't be an answer.
Principle that a match or this light bulb, emits light. It doesn't emit anything, of course, at the same speed as the sun.
Of course, it doesn't emit anything. Of course. So we'll just deny the fact that the mass of the substance changes, and we'll deny that energy goes in, that it costs something to create this, whatever it is.
A super gigantic fusion reactor is ridiculous. Strike a match, light is emitted at the same speed as from the sun. Well, that makes no sense. Oh, what?
I don't know why it wouldn't make sense. I mean, it's sort of temperature issues in in the crudest sense. You get thing up to a certain temperature, the electrons start breaking down, photons start flying out. Too much agitation, too much shaking, and bits fall off. That's understandable. Bits falling off. Perturbations falling off and perturbating. Okay, coaxial cables flapping off. I don't know. Sorry.
It does make sense is that it is a field perturbation.
Okay, a field perturbation. So that's let's just say that's an impulse, right? Do we have to use perturbation? Can you just say a field impulse? So it's impulsed. The field is vibrated, and the vibration is felt at the other end of the field. Right? That would be the definition of your ether. There's nothing coaxial about that, that I can understand.
Ether perturbation. The notion that this light bulb or match or the sun is actually emitting something is an absurdity.
Well, you keep saying it's absurd. I don't think it's at all absurd to recognize there is a gain of mass and a loss of mass in many of the obviously in many of the relationships we can experimentally observe with photons, and clearly something goes from here to there, not nothing. But again, you don't give me a definition of what the something is made out of anyway. It's just all vibrations or perturbations, I mean, technically, that's the distinction. I mean, the space surrounding me has just as much energy in it as I possess. It's just in a different form. This energy is doing orbits, that energy is not. This energy is doing frequency, that energy is not. This energy is polarized, all in the same vectors, that energy is not. Is that your argument? I mean, there might be more common ground here than could be imagined if you're not obnoxious to the fact that if you look at the ether and say the ether composes everything, that the ether, and that just recognize that it's a quantizable ether. It has definite components of amount. Amount exists, and things come in amounts. It's quantizable.
If there's nothing in the whole universe other than this light bulb and you plug it into some unknown socket, do you think that anything is being emitted from this light bulb?
Yes, that's how it gets across the whole frickin' universe. flies all the way across space, the little photons. And they do it in this scattered way, like a machine gun scattering bullets. It's so similar that why wouldn't I think that's what's happening? That's what it has every appearance of being, something that's spewed, okay, in a you know, whatever you call this, a complete range of vectors, and the density of what I receive will be dependent on my distance. I'll get more bullets the closer I am.
No, it is a field perturbation. If someone is in the middle of a lake and flapping their arms...
So you say, okay, so now we're in the middle of the lake and we're flapping our arms and we're creating vibrations in the medium, and the vibrations will be felt by some other structure, and they'll be perpetrated by it. But again, what's the difference? If I take away the medium and I just turn the wave, the flapping of the arm, into the spewing of particles, and the particles go across, and what's the difference?
Water splashing everywhere. Do you think that, and the waves actually lap up against your feet along the shore, do you actually think that the person is actually reaching out and touching their feet? That, they're emitting something? No.
Yes, but again, so what's I'm just saying that, yeah, for practical purposes, if you make the entire space out of a solid and that you can vibrate, okay. I mean, I can't say that's wrong, but I'm saying, what does that have to do with the quantizableness of the discrete vibrations? And where is there any necessity that they hyperboloid, or that they have any other feature than the obvious feature of there's frequency? The quicker I flap my arms, the quicker the frequency. And clearly, the other distinguishing feature I'd say that is necessary, somehow you have to explain, is the nature of this polarization, which makes the conveyance of the perturbation more or less intense to the receiver. The receiver can see it or not see it based on polarization, feel it or not feel it.
No, they're not. It is a perturbation in the water that they're flapping their arms in.
So instead of just saying a vibration, you use perturbation. Is it for some good reason?
It's the same thing with this light bulb and everything else. Light is not emitted from this light bulb any more than it is emitted from a match or the sun. Think about that the next time you're on the high...
I still don't understand. Think about what? The non-emitted light. There's no point in me doing that. Think about how the space between me and the light is getting shorter, and I can think lots of things, and I can think, well, coaxial something. What's the coaxial part? And it's certainly not instantaneous. And so what's the ether made out of?
Away or something, you see spotlights or something, somebody else's car headlights, shining at you.
I mean, we know why all mediums that transmit waves, like water, or even solids that transmit, vibration, we know why they do it. It's because they are rigidly connected in terms of they have an equilibrium, and they maintain that equilibrium. It's back to the inertia argument. The inertia is hard to overcome. So they maintain their inertia unless there's sufficient force to knock pieces off. And they maintain relationship to each other. But that's a force dynamic. The forces are actually holding them together. So again, how does the inertia maintain the integrity of the things it's holding together? How do the things get held together if the inertia... how do things get held together if the ether isn't actively pushing them together? The inertia. I mean, what is your explanation? Just say that the Earth it's magnetism that's causing the Earth to fall into the sun. Undetectable magnetism, right? There's clearly not enough detectable magnetism to do this. So you have undetectable magnetism that's hurling the sun into the Earth into the sun by your theory, and still there's no explanation of the energy. Where do you derive it from?
that is emitting light, it's a field perturbation. Like, stick this in an absolute vacuum, which humans cannot recreate, which basically does not exist, and light will manifest. Pump a charge through this, a discharge occurs. That discharge is like someone flapping their arms in the middle of a pond or lake. It's a field perturbation. The Michelson-Morley...
Right, a field of what? A field of ether that is somehow inconsistent depending on what matter the ether is in. Is matter ether? I mean, it's just not explained well enough.
Experiment never disproved the ether. It did not. Nobody can
Well, I don't think you can disprove something that's invisible. Yes, that's difficult. And so, yeah, I would say that that's kind of a bogus claim, that something that doesn't create drag, and then you say, look, here's an experiment proving there's no drag. Well, we already know there's no drag. I mean, we already know that stuff hurls through space without being slowed down going through it, so why do we need to prove that? That's already known. The fact that somehow that can happen, obviously there's a rule about the ether that allows it to be frictionless, so, it seems kind of silly to say you prove the non-existence of something where the claim is the something already has a faculty to overcome your proof.
Through the ether, because everything is fields, and fields are not particles. Let me actually...
Yeah, fields made of what? Fields of what kind? I mean, just nothing here explaining anything. It's just this claim, well, things attract, things repulse, la la.
Quote Nikola Tesla here in a little bit. James Clerk Maxwell, this medium of propagation, the ether, must exist. The medium must be a predominant thought in our investigations. Right.
And I'd say Maxwell is getting close to it too. But they couldn't deal with one element of a particle gravity, and because they couldn't think in terms of how do you get rid of the heat or the friction, and they just didn't think, they didn't do enough physics, and they didn't recognize that on the particle level there is no friction. Once again, based back to that argument that if I had a collection of ball bearings in space, just a ball of them, let's say 100 of them, and I perturbated them and they scattered, they'll go forever. And if I put them in a sealed container, a container where they can bounce off of something in the same way they bounce off each other, they will bounce around forever.
Okay, there are only two possibilities: a medium, i.e. ether or inertia, or nothing, i.e. space. And nothing...
Those aren't the two choices, right? But I'm just saying, well, obviously the nothing would have something has to be in the nothing. So yes, the nothing, there's nothing, and then there's something in the nothing that's active, not dead. But a dead ether is kind of useless doesn't explain anything. The only thing that matters are the moving parts of the ether.
Nothing acts on nothing. Nihil ex nihilo.
Well, you're claiming the same action. You're giving me no explanation for the force. What creates the force? What generates it? And it's certainly in the case of the Earth and the Sun, there's no loss of mass. There's no conversion of anything into energy. And yet clearly, there's a tremendous amount of energy being utilized as force. So where did the force come from?
Notion that space has properties, or space that acts on something or does something, is an absolute brain fart.
Well, I would say I agree that it's not a great idea. So, but you've said this over and over.
For your credentials, or offer their credentials without...
Right, so again, well, why are you arguing with dead people and people who won't talk to you? I'm here to tell you I believe in particles. I believe in a particle-driven universe. Real material universe. Nothing fluffy at all. Not a single perpetuating wavy thing at all. Nothing having any character beyond a piece of mass, an element of 1 uno of mass, moving the speed of light, and that the entire universe is just made out of these little bits moving the speed of light, and that's all there is. Everything, every known phenomenon is made out of that event, a thing moving the speed of light. And everything moving slower than the speed of light obviously has a bunch of speed of light stuff not going in straight lines inside of it. Obviously.
Oh, you asking for them, or about them. Nothing is more fantastical and a travesty of how nature works than is quantum theory. It's very...
So this is a Tesla quote. So Tesla was very anti... look, I'd say bent space, he was right. It's a silly on its face. It's not a really good explanation. It doesn't explain where the energy comes from. It really isn't reasonable to just make up a fake arena, a fake place that forces the math to work, that creates your inverse square rule, because it's just built into the fake space. How convenient.
Of the cult of quantum. Everything we call real is made up of things that cannot be real. Oh, okay. Here's another priest of the cult of quantum.
Well, aren't you saying that? Aren't you saying that everything real is ether perturbating? I mean, obviously nothing that's real, nothing that is what we see is made of what we see. I'm not made of Gary. I'm made of a bunch of bits of crap in different configurations, quite obviously, different orientations. We know the chemistry, and we know some of the physics. So, well, why pretend that nothing's made of what it appears to be from our senses? Our raw, natural senses aren't going to be able to see reality.
Quantum, one of the most insane morons that ever existed. He is praised endlessly. He has a cult following around this demented...
Yes, okay, and I'd say exactly the same thing. This whole frickin' Tesla cult following is just so silly. He pretty unarticulate, phantasmagorical guy who, beyond... Look, they all have their contributions, so to speak, but I mean, beyond recognizing one simple thing... that AC current has advantages in terms of you can fool the magnetic field with this oscillation. You can break the freezing of function that happens when you don't have a field in flux. Yeah, so good on him for that. But other than that, what's the contribution? He spent a lot of money pretending he could send energy through atmosphere, which doesn't make much sense.
Devil, more than anything you can imagine. Richard Feynman. The more you see how strange nature behaves, the harder it is for us to make a model that explains...
Yeah, so, and he gave up on that. It's harder it is for us to make a model, because he just didn't want to, I mean, they're smart guys, and then they basically said that because we can't do it, I mean, they were that arrogant, Me and Einstein can't do it, so fuck it, nobody can. I mean, that sort of was their attitude, and it was really very unscientific.
And I'm going to go looking for the Omicron particle, which, my math...
Alright, so he's talking about the super colliders and what money gets spent on. I would agree that it's unfortunate that, there wasn't more paths to the road to finding the truth, and they just invested all the money in the phantasmagorical theories, the premises, and just said, well, let's not even re-examine the premises. Let's not spend any money examining premises to see if they actually have any validity.
Dazzles and make people blind to the underlying errors. The theory is like a beggar clothed in purple whom ignorant people take for a king. Its exponents are very brilliant men, but they're metaphysicists rather than scientists.
Now, I would say that's Tesla talking about Einstein. And again, it's just, I could just turn that right around and just say, what was his contribution? I mean, a bunch of phantasmagorical woo, a bunch of, well, the ether is perturbating. That's not a very good diagram. And you really have to deal with the fact that it is quite obviously, the force dynamics have rules. There's rules of conservation, and the quantity is there to be quantified.
A single one of the propositions of relativity have been proved. And that's still
Well, in Tesla's time, that may have been true. I still say that the idea of relativity is the bent space argument. Yeah, they'll never prove it because it's not true. The other things are just assumptions. The assumption that light can be bent is an assumption, and I think it's just a wrong guess. Yeah, just from the force mechanics. Light is a force. Forces do not bend forces. You have to bend the electrons or the matter to make light behave differently.
still remains true, even through the gravity wave nonsense, which was not proven. It's a farce.
I would agree it's a farce to say that to go as bold as they have gone, what they've detected and whether it's cosmic or not. I just think it's too many assumptions and presumptions built on that statement of fact.
To say that in the presence of large bodies, space becomes curved is equivalent to stating that something can act upon nothing.
Right. Well, your whole premise is that everything's curved. The ether's curved all over. The hyperboloid is somehow, it knows to curve. You're saying it's not some crack whore. Well, it seems pretty crack whory that it knows how to do all this stuff you're saying it's doing, and it's somehow, it's smart like that. Yeah, I know. How does it get smart like that? How does it figure out to hyperboloid? And again, just understand, I'm not arguing against the idea that there's a byproduct shape conformation, but there's obviously in magnetism there is no hyperboloid of the force. The field lines are as linear as the object they're coming from. So if you have a flat magnet, you're not going to hyperboloid around it. You're going to go into flatter dimensions, coherent to the magnet's shape.
Nikola Tesla. My conclusions differ from Einstein's and to that extent disprove Einstein's theory. My explanations of natural phenomena are not so convoluted as his. They are simpler, and when I am ready to make full an announcement, it will be seen that I have proven my conclusions.
Right, so that never happened, and that's, so Tesla is God, even though he never did that. So it's like, I'm sorry to say, but that just is so much more ludicrous, going with the guy who never even completed the task, never even explained, never put something on the table to be mocked. Here you are mocking people for putting something on the table, and Tesla put nothing on the table. A vague notion of a transmitting ether that still doesn't explain where the dynamic of doing actually comes from or how it's passed through different media.
Tesla said of the theory of relativity, a massive error and deceptive ideas.
Yeah. I agree that relativity is not the answer.
You thought immutable. I am much too ignorant, my son, for grasping crazy schemes so finely spun.
Yeah, that was some kind of poetry by Tesla. Well, gee, isn't that special? So tiny scientific. Poetry is so helpful in doing science.
Everything in the universe is actually very, very simple. It's not simplex, but it is very simple.
Yeah, well, whatever that means. It's not simplex, but it's very, very simple. Well, I think things that are very, very simple are supposed to be simplex. I think that's sort of what these adjectives and adverbs and whatever, that's how those words are supposed to work. So things that are wet are soggy-ish, yeah, simple should be simplex.
Force and motion and inertia and acceleration. That's all that needs to be understood.
Force and motion, inertia and acceleration. Right, very basic concepts. Things have velocity, and you can change their velocity with some new acceleration in some new direction. A force-initiated acquisition of some new acceleration. So through what mechanism you don't provide.
Good. That is the conjugate nature of the universe.
Conjugate. Okay, that's a word you didn't need either.
Things get extremely complicated when you compound these things upon each other. But the underlying principle...
Well, agreed. The density of it does make it impossible to follow all the little happenings because there's so many. There's a universe as big as the entire universe is. The little stuff in this one little square meter of space that I occupy is more dense in stuff, identifiable things. I mean, if I said planets are just a single planet, not made of atoms, if you just take the big universe as just bits, rocks, yeah, there's more rocks in this meter of space.
Principles of field mechanics is very, very simple. There's only one field. The notion that us stupid humans...
Right, there's only one field. You previously criticized people for attempting unification theories, and then you say there's one field, and that there's no point in unifying. There's, you know, and you used the word fields before, you know. So again, these are sort of like contradictions that aren't very helpful to understanding either.
Beings are trying to unify, you know, these forces and fields together is ludicrous.
See, I mean, you just said there's one, and then you said it's ludicrous to unify. I just don't. Sorry, that's a non sequitur or something.
It is insane to someone of great wisdom as someone trying to unify steam and ice and water. It's all water. Now we're trying to unify.
Yeah, I'm just saying, well, isn't that the sensible thing to do, is to find the common denominator, the common function, the common quanta of function. So what's wrong with that? So this critique is silly.
No, asshole. It is all water. Steam and ice, water, it's all the same damn thing.
Well, I mean, I don't even know if there's any point in saying that, because obviously the ions are different than the non-ions, and the properties are different depending on the amount of heat. So I don't know. I don't think that's really a useful thing to say.
All field modalities. There's only one field and three field modalities.
Okay, there's one field and three field modalities. So there's a field modality.
Inertia?
That's a field modality. So the field has inertia. The objects in the field don't have any. The field has the inertia. Okay. So how does the field travel with something when it's moving?
There's a loss of that inertia, and
Alright, I don't know. The inertia is flat, and then loss of inertia is pop. What does that mean? Loss of inertia, by that you mean change, and that's called acceleration. You're not losing inertia, you're changing. You're dynamic. A force affects you. I mean, to call it loss of inertia, you still have inertia. In your new state, you will have inertia. Every new state is a new inertial state. How can you... I mean, you just can't use these words this way. I mean, you have to have some respect for how words... I mean, the traditional meaning of words within the science. And it's like you're kind of just breaking those traditional meanings to say that this thing had inertia, and then in this new state it doesn't have inertia. No.
There are two modalities. Electricity is phi times psi equals Q in Planck's law.
Well, that's all pretty. Electricity is phi times psi, blah, blah, blah. You can't even write it down on a piece of paper, put it in the background here so I can see the formula. But whatever. Yeah, I have my own theory on what electricity is, okay? Electricity is the movement of electrons, and they move because they're in a field. And that field makes them repel each other even more than usual because they're polarizing the field and creating more stink. Electrons stink in the air.
Electrification. Electricity is a hybrid of dielectricity and magnetism.
A hybrid of dielectricity, whatever that is, and magnetism. So, you know, whatever. I would agree that electricity and magnetism are connected and the same force is creating both. That's it. The same polarization. One is a surface phenomenon, and one is a density phenomenon. Magnets have a thicker polarizing field.
And that which we call gravity is no different than dielectric acceleration, or what we call magnetism.
Yeah, dielectric acceleration. That is simple. Dielectric acceleration. Now, if I was to put like the 500th simplest words or simplest phrases ever spoken in the English language, dielectric acceleration would be somehow in that top 500. That's a simple to understand concept. No, I think it'd be in the bottom list somewhere. If I ask 100 people what that is, nobody's going to know. You know that, don't you? I mean, honestly. I'm asking you honestly. You think if you walk up to 100 people on the street and say dielectric acceleration, they're going to tell you what that means? It's going to agree with your definition? Come on, be honest, Ken. Come on. So you know you got to do better than that.
Kinetic attraction.
Right, attraction. La 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 la. Magic force, magic force, magic, magic, magic. Magic attraction. Da, 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 da. No mechanical process necessary. Just magical. I love you. I go move towards you with magical energy, and I'll magically walk over there with no legs. That's all. You're just basically saying the acorn jumps over there. Okay, without, it doesn't have any legs, doesn't have any way to jump, but it jumps over there. I don't think so. That's simple. No.
Now, magnetism is a field divergence. The notion that...
Okay, a field divergence. Now, if I go up to everybody and ask them what the fuck that means, what are they going to say? Well, what do you mean? Okay, it's a field that's against the field? There's something moving against the field? Magnetism is moving against the field? I don't think so. I think it's making a field. Yeah, it's making a field. That's what it's doing.
That radiation is attractive is ludicrous.
Radiation is attractive is ludicrous. Well, it isn't ludicrous if you understand that if you polarize the radiation and make it invisible coming out of one side and it's still visible behind you, okay, that the push is still going to exist. And if the push still exists and there's no push from the front, that you're going to go the way the push that still exists wants you to go. Yeah, too bad. You're going to move. You're going to be attracted whether you like it or not, but you're going to be pushed. You're going to be repulsed into it. Yeah, you're going to be repulsively pushed into your attractive circumstance.
But everything in Mother Nature is curvilinear. There's not a single straight line.
Okay, there's not a single straight line. There's a straight line on this video, for fuck's sake. How do I make any sense of that? There's no straight lines except all the the internet's covered this box is pretty fucking straight. Everything around here is goddamn straight as fuck. So I don't know. What the hell does that mean? Oh, yeah, it doesn't mean a damn thing. It's just fluffy words to throw in here.
In the universe, as you can see from this hypertrochoidal formation.
Right, that's crookedy, and the edge of your desk is straighty. So I don't know. I guess I could see the hypertrochoid is crookedy, but I don't see where all the other stuff is crookedy because that's crookedy.
That forms the torus. You can actually see the curvilinear pattern that goes from one side to the other in a curvilinear motion. And if you look right over top of it, you'll see a hypertrochoid, just like you do over top of a ferrocell.
Yeah, well, a ferrocell is not exactly what you call a scientific instrument. So you want to say that it's actually demonstrating the proper field lines without any distortion? And I'm going to argue, oh, hell no. It's doing exactly the opposite. It's the distortocell. That's entirely what it is. You're looking through a fluid that is essentially creating a lens by compression. All the fluid goes where the magnetism is. It's less dense where the magnetism isn't, and you're essentially just lensing the fuck out of whatever you're looking at. That's not a scientific instrument. I mean, yeah, it's could be used scientifically. I'm just saying you have to understand that it's not giving you a vision of reality. It's distorting your view of reality. An obvious distortion. Because if you saw the real thing, you'd see all the damn fucking straight lines pop back on. And I think you know this.
Very, very simple. Inertia, loss of inertia.
Yeah, well, take your ferrofluid and see you come up with all these crookedy lines coming out of the top. It's, there's no, it's pretty rigid. The rules are pretty rigid. The vagaries of where the lines will be created, again, just has to do with the fact that of this repulsive effect. I mean, once established, they'll find balance. That's what electrons do. They find balance. They don't stop until they find it, until they fall in it. They have to fall into a place that is quiet, or they're not going to be quiet. So they don't stop until they find a place there's no wind.
Force and motion, inertia and acceleration.
Alright, force and motion, inertia, acceleration. Yeah, I would say that there is this thing called force. There's what we see as material velocity. And so instead of force and motion, I'd say, yes, there's force, and then there's material velocities. And what's the other thing he says?
Force is literally that simple. Mother Nature is not, a crazy witch with a calculator.
Well, you're saying she is, but she calculated all this crap, this whole hyperboloid bullshit. That seems pretty fucking crack-horror-y, calculatory.
As quantum mechanics and relativity would have you believe.
Well, quantum mechanics wouldn't have you believe any of that, so I don't know where you're getting the idea that... well, anyway, I again, argue with somebody willing to defend particle physics, and I'm willing to defend particle physics, and to argue against any notion that waves exist as anything other than particles moving through mediums.
Not that difficult. Now, the universe is incredibly complex, but that's only because you have one structure overlying another structure meshed with another structure.
Well, see, that's my argument would be, though, is that no, it's only complex, yes, in the density of it, but the function is always simple in the sense that underlying all function is this bit moving the speed of light. There's just nothing else happening, and the rules, polarization, frequency, and the rules of orbits. That's it.
Structure, but the simplicity behind all of it is divinely.
Won't even say orbits, swirls. Compaction. So I'll use a word. Compaction and inertia or something. Compaction and, I was trying to think of a quick way to say polarization that comes out of that compaction.
Simple. It couldn't even be more simple. I mean,
well, again, you keep saying that it's simple, it's simple, it's simple. I don't, no, sorry. I don't see it. I sit there and I close my eyes and I say, imagine, nothing.
It's impossible to even imagine something more simple than that.
Well, I have imagined something much more simple. Yep. Just a bunch of little bits traveling the speed of light that can acquire properties when they are condensed, pushed by the field force into association.
And here we are running around like morons trying to unify what was already unified. We're complicating things that are not...
Well, again, unify what is already unified. So you're arguing against the process that you say is the inevitable result. So again, the idea to unify is not a negative thing. It would be a positive thing. You're just disagreeing with what they're unifying around.
Not complicated, but very principled. And that's just because we're stupid humans. Thanks for watching, and I'll catch...
Well, I would agree that some of us are stupid. Some of us have... little bit of knowledge is a dangerous thing. I said that. That'll have to be the thing, the cliche of the week or the month. And so I mean, you can be intelligent and yet one bad premise. Garbage in, it's all garbage out. One bad apple spoils the intelligence pie. Yeah. One bad apple spoils the intelligence pie. One bad apple can spoil the intelligence pie. you can break a good intelligence with just one or two bad ingredients. Just a couple of wrong presumptions and you're in big trouble. And I'd say the presumption that Tesla made any, it had a brilliant diagram of reality is a tragic presumption on your part. So anyway, throw this out there. I'll post a link on your video and see if anything happens. Like a response video. Yeah. I don't mind opening a room if you're willing to come into it. And we could argue this stuff. Because I can certainly send you the link and you'll be able to talk in the room. So if that's agreeable. Anyway, but I think making videos is a more disciplined way to have a conversation. It's safer. People don't end up talking over each other and whatnot. Anyway, till next time. Such.